Bless you. All right, so it says use graphs and tables to find the values. Essentially, we're just going to be more or less talking about them. But we're finding for the first few problems, A is the limit as x approaches infinity of f of x. B is the limit as x approaches negative infinity of f of x. And then C is any horizontal asymptotes that are there. So that's going to be our Bobo, Botno, Bosco from, well, Algebra 2 and Pre-Cal when we discussed horizontal asymptotes. So the first one is f of x is equal to the sine of 2x over x. So A, the limit as x approaches infinity of the sine of 2x over x. So basically this is what's happening as x is getting really, really big. So the sine of a really big number, a lot of times I like to think of it inside of the function. It's a little bit easier to think of it as like a, probably like 50 inside of like a trig function, but outside of it I usually think of like 500. Essentially what's happening as this gets really, really big in the positive direction. So if we did like the sine of, I need to see what mode I'm in, hold on. Oh, it isn't radian, okay. I hope Cash didn't take his quiz yet. Oh, I didn't write it, it wouldn't have mattered. The sine of, I'm just going to say 100 in radian mode, is a really small number, essentially. So this would be like, basically if you did the sine of 100 in radian mode divided by, say, 500, you're going to get a really small value, right? And so this would be approximately equal to 0. Basically, these limits, in most cases, unless things reduce, your limit at infinity is either going to be 0 or infinity. Now, if you have a horizontal asymptote, it is possible that the limit is going to whatever that value is out at infinity. But we'll see that as, that's part of why they're asking you about horizontal asymptotes. So it's almost like you need to do the question in reverse. But now, if I do the limit as x approaches negative infinity, and I choose a really big negative number, so say I do the sine of negative 100, that's giving me a positive number divided by, say, negative 500. And when I do that, I'm getting the same number I had before, basically exactly, right? And so this ends up being also 0. Now, most of them you won't really need your calculator to evaluate just because this one has a trig function. It's easier to see with that. But we'll talk about that with the next question. So then horizontal asymptotes here, we want to discuss if we have any and what they are. So Bobo, Bosco, Botno, bigger on bottom, y equals 0. Bosco, if they're both the same, we use the coefficient that's in front of them. And then if it's bigger on top, so Botno, then there's no horizontal asymptote. Now, with that, we never really talked about, okay, what happens if there's a trig function on top. But that x value is inside, so essentially that's would be classified as something like smaller. So it would be, this one would be bigger on the bottom, if it's like inside of a trig function like that. So this would be bigger on bottom, so my horizontal asymptote is at y equals 0. And so then here, my limits being 0 makes sense. So, and they won't always necessarily, like I said, be exactly the same, but if they are, it would help it to make sense. 4, so same instructions here, just different problem. F of x equals 3x cubed minus x plus 1 over x plus 3. So anytime I'm dealing with limits at infinity, all I care about is the highest powered term, top and bottom. So all I care about for the sense of this is this 3x cubed over x. The other stuff out at infinity isn't going to change anything. So the limit as x approaches infinity of... Now, a lot of times I don't rewrite the whole function. I kind of did up here, but a lot of times I'll just write f of x because it's clear what it is. So if I plug in like 500, okay, top and bottom, and all I'm looking at is this, what's going to basically be happening if I just look at these two values?
It's just going to keep going up.
Yeah, it's just going to get really, really big. So we would just say that that's going to be equal to infinity. Because all I can literally look at this as 3x cubed over x. Well, that would reduce to 3x squared, so I know that's going to be a really big number, essentially. So then the limit as x approaches negative infinity of f of x is equal to, well, if I plug in a really big negative number here, even if I leave it as just 3x cubed over x, a negative over a negative is going to be a positive. It's going to still be a really big number, so it's going to be a positive infinity. So these, like this particular one, should look a little bit more like when we did in behavior previously, and we were just looking at, like, I don't even remember what section it was in pre-cal. Somewhere earlier in the year we did it when we looked at the in behavior, but we were basically saying, is it a really big number or a really small number? It's more or less what's happening here. So then horizontal asymptotes. Again, we only care about the highest power, so this is bigger on top, so it's botno, so that means there's no horizontal asymptote. So I usually just write none or no HA or something like that. Let's see. Number 6, f of x is equal to 2x minus 1 over the absolute value of x minus 3. So the limit as x approaches infinity of this function. So sometimes it throws people for a loop when there's an absolute value in here, but the x power is still just x, right? It's still just to the first power. So when I'm evaluating this problem, I want to pretend like the absolute values almost aren't there. The only place it's going to play a factor is our horizontal asymptotes, basically. So I essentially have 2x over x, and I'm finding what happens. So this is one where those essentially would cancel. The x's top and bottom would cancel, because if I have 2 times 500 divided by 500, 500s are going away. So this is going to be equal to 2. So this is one that's not at 0 or infinity, but we're going to end up finding that it is at one of the horizontal asymptotes. B, the limit as x approaches negative infinity. So this one's also where the absolute value is going to slightly come into play here. I forgot about this one. So we've got essentially 2 times negative 500 over the absolute value of negative 500. So the absolute value of negative 500 is going to become positive. So now I have a negative divided by a positive. Even though those values are canceling out, essentially, we still almost have like a 1 there. So that's going to be negative 2 is where this one's going. So then my horizontal asymptotes, if they both have the same power, we use the coefficient in front of them. But I know up here that the coefficient is 2, but the coefficient down here could be a positive 1 or a negative 1. So I have a horizontal asymptote at y equals 2 or at y equals negative 2. And I think I want to say last year when we did stuff with asymptotes, that's when we did a few things with limits. So essentially they're confirming what you've got. Limits confirm your horizontal asymptotes. In this case, they're just having us do them in the opposite order. Find the limit and confirm your answer using the sandwich theorem. So the sandwich theorem essentially says find two things that you know the limits of, where one's negative and one's positive, and you know that the value that they've given you in the problem is between that. And then based on what those limits are, it tells you what the limit of the other piece is. So 10, we've got the limit as x approaches negative infinity of 1 minus the cosine of x over x squared is equal to 0. Or, well, I just told you what it's equal to. Whoops. It'll make sense in just a second, but so what we would do with this one is we would say, okay, well, something that I do know is 1 over x squared. Okay, I could find the limit at negative infinity of that. So I'm going to say that I know this value has to be between negative 1 over x squared and 1 over x squared. So then I would just put that in the middle of it. So I'm sandwiching it between the two values that I know. So 1 over a really big number is approximately what? Like 1 over 500 is approximately what? 0. So that's approximately 0. And obviously that was the negative version. The positive version is still going to be basically 0. And so I know that this limit has to be between here. So then by the sandwich theorem, I can never spell the word sandwich. I don't know why this word throws me for a loop every time. But anyways. So by the sandwich theorem, the limit as x approaches negative infinity of 1 minus the cosine of x over x squared is equal to 0. So, most of the time, well, almost every time, we use the sandwich theorem with trig functions because we don't necessarily know that. Now, we could plug in a really big number and confirm this and say like 1 minus the cosine of 500 divided by 500 squared, and it would be approximately 0. It would end up like this one did up here. So this problem could also be done using the sandwich theorem as well. There's a similar one in the sandwich theorem thing, but I can pretty much guarantee on either the quiz or the test you're going to have a question where you need to use the sandwich theorem, and you're literally just showing this. Essentially it's always going to be 1 over whatever the denominator is, find whatever that value is, and then that's what it's equal to. So it's not anything too crazy. It's kind of just annoying, but it's obviously there for a reason because otherwise we wouldn't be able to solve it. So that's how you would essentially solve it without a calculator, I guess, is the moral of the story. All right, these say to use graphs and tables to find the limits, but we can really just do this with some kind of like rough thinking. So we're obviously dealing with limits at infinity a lot in this section, but this section also has like the limit as we approach a value from the left or the right, and some of those are going to be going out to infinity. And so your answer to your limit could be infinity, or you could have a limit at infinity and figuring that out. So these ones, number 14, we have the limit as x approaches 2 from the left, so that would be with the little minus sign, of x over x minus 2, and we want to say what that is equal to. So 2 from the left would be approximately something like 1.99. So I would take this and essentially plug in 1.99 over 1.99 minus 2. And so on top, I would have 1.99 divided by point, what was that, 0.1? Yeah. My paper's missing the 0. So if you evaluated that, what do you get? Yeah. So basically, pretty big number. And so that would tell us that this is going to, the bottom should be negative. So that's going to negative infinity. Because 1.99 minus 2 should be a negative number. Just forgot to write the negative. So that would be going to negative infinity. 20. The limit as x approaches pi over 2 from the right. And normally if they do something like this, they're going to put the pi over 2 in parentheses just so that it's clear that what it's going for, of the secant of x. So the secant of pi over 2 is 0, right? So we're looking at from the right. So I would say something like the secant of trying to think of like a value that we would know that would be easy to use. So is that pi over 4, pi over 6, pi over 4, pi over 3. Something like maybe like a 5 pi over, 3 pi over 8 or something like that you could plug in and see what it's equal to. And so the other way you can think about this, where the graph and table part might come in handy a little bit better instead of trying to think up a value and plug it in. Secant goes with cosine. We know the parent function goes out to 2 pi like this, and then it goes up between 1 and negative 1. So if we did cosine starts at 0, goes up, comes down, blah, blah, blah. Now, this is pi over 2 right here. Secant goes off of this. It makes almost looks like a parabola going up like this. So as I am getting to pi over 2 from the right, what is happening to this graph? It's going where?
Up.
Yeah, it's going up toward, or wait. Hold on. Is that right? Do I have this drawn right? What is going on? Now I need to check it. Hold on. Cosine of trace Is this supposed to be pi over 2? I'm so confused. Hold on. Pi over 2 from the right. Because I have that it's negative infinity. Well, the book has that it's negative infinity. So I'm trying to look at the graph here and figure out. Let me see. Trace. Nope, not trace. Second trace. Value. I'm going to do it at pi over 2.
Try printing something.
Work right now?
You have something to print.
I don't at the moment.
That's fine. I think I figured out the problem though.
Oh, thanks. You look like
Okay.
you've gotten a little messy. Your hand.
Black. Fine. So it's fine.
Thank you.
You're allowed.
Uh, is not letting me find what I'm trying to find. Well, now I'm confused about what's going on here. Did I draw this wrong? Secant goes with cosine, right?
Yes.
Oh, wait. I know why I'm confused. Because I drew the graph wrong. Cosine does not start at 0. Cosine starts at 1. So it should have been here, then here. So this would be like this. I was like, why does the graph on my paper not look like the one on the calculator? And then I realized. So basically we'd have something going here, and then we'd have one going here. So this is secant down here. To pi over 2 from the right, it would be going down to negative infinity. There we go. I was like, something is just not working. And anyways, haven't done trig graph since last year, so. I was like, the value that the calculator is giving me is telling me this is going to negative infinity, but it is not working when I'm doing it on my paper. Anyways, okay. The limit as x goes to infinity and x goes to negative infinity. And obviously a lot of the ones that we've done so far, well, I say a lot, maybe I lied. Several of them go to the same value at negative infinity and at positive infinity, but that's not always the case. But a lot of the times it does work out that way. So 22, y equals, in parentheses, 2 over x plus 1, and then times 5x squared minus 1 over x squared. And we're looking at the limit as x goes to positive infinity and the limit as x goes to negative infinity. And did not have to write the whole thing. We usually just write whatever they're calling the function, so. All right, so if I plugged in a really big number here, say like 500, it's my go-to number, I would have 2 over 500, which is basically just 0, plus 1. So essentially, I would end up with 1 times over here. I don't even need to worry about the 1. X squareds would be canceling, and so I would end up with just 5. So 1 times 5 is 5. Then at negative infinity, I'm essentially going to end up with the same thing. 2 over negative 500 is basically just 0 plus 1, so that one's also 1, and then times, well, they're still going to basically just be canceling, and so I'm left with 5. So these both happen to also be the same value. So these limits are both 5.
How come you don't subtract the 1?
Because at infinity, the 1 is meaningless, essentially. So all I really care about is the really big number. Let's see. 24. One with the trig function. Y equals 2x plus the sine of x over x. So the way that I would look at this is essentially by breaking it up. So we have the limit as x approaches infinity of y. Now, if you can do it without having to break it up, obviously that's fine. But you can also break this up into like 2x over x plus the sine of x over x. And the limit of the sine of x over x is just, 1. So, because that was, or No, it's 0. Hold on. Now I'm questioning it. One second. Yeah, the limit as x approaches infinity of the sine of x over x is just 0. So that's going to 0. And so then the other one would just be, when you cancel that stuff out, it would just be 2.
So how come it was 1 before?
I may have written it wrong in the last section. Let me look. That was as x approaches 0. At infinity, it's 0. So at 0, it's 1. At infinity, it's 0. So I was like, wait a minute. We weren't doing limits at infinity before. So then, same thing's going to happen here with the negative infinity. Limit as x approaches negative infinity of y is equal to positive 2. Because again, they're essentially just canceling. Okay. Let's see. Next thing, 28. Find the vertical asymptotes of the graph. Describe the behavior of f of x to the left and right of each vertical asymptote. So essentially, we're looking at what's happening as x goes to the left and the right, or from the left and right of the two or whatever values for our vertical asymptotes that we have. So 28, f of x is equal to x squared minus 1 over 2x plus 4. Do you remember how to find vertical asymptotes? No, it's been a while.
It was like at the bottom equal to 0.
Yep. So you set the bottom equal to 0, so 2x plus 4 equals 0, so x would be equal to negative 2. And they're always equations like x equals something, just like horizontal asymptotes, or y equals something. So then now what they want us to do is say the limit as x approaches negative 2 from the left of f of x, and then we'll also do the limit as x approaches negative 2 from the right of f of x. So negative 2 from the left would be something like negative 2.001 or something like that. So essentially I would have like negative 2.001 squared, because all I care about is the highest power, over 2 times negative 2.001. Well, those are going to end up being pretty, well, I say they're going to be pretty close together, because 2 point whatever squared is going to be like 4 point something, and then 2 times that, it's going to be pretty close, but it's going to end up being bigger on the top, obviously, and the bottom's going to be negative, so this would be going to negative infinity. Up here, the next one from the right would be like 1.999 or something like that. So that's squared over 2 times 1.999. So this one's going to be positive because I don't have any negative. Well, I guess they're technically, I say that. We have negative value there. What number is this? Hold on. I need to check that. So that ends up being something like 4 over, well, almost. check this answer in the back. I think I have it written. What number is this? 28. Positive infinity. Oh, I know what I'm forgetting. Because these ones are going to make a difference if we... So, let me backtrack here for a second on this previous one. I keep mixing up I'm forgetting to do this. The only time we care about the highest power term only is if it's at infinity. These are not at infinity, so I need to be including this -1 and this +4 down here. Because this one is still gonna be, because this is still gonna be a -4 point something, it's still gonna be negative here. So it would still be like a positive over a negative. So this is still gonna be at negative infinity. However, with this one, if I change it and I do my -1 and my +4, this is going to end up giving me a positive number on top still. And then down here, this is going to be like something less than 4. So a negative number that's less than 4. And then +4 is going to be a positive. So this one's going to be at positive infinity. So at infinities, we only care about the highest power term. If it's anything other than infinity, we need to look at the whole function. So I think otherwise we've done it. Yeah, it's been fine. Okay, let's look at another one of those. 30. F of x is equal to 1 minus x over 2x squared minus 5x minus 3. So we're doing the same things here, finding our vertical asymptotes. So we're going to have to factor this one because obviously this one isn't already in a factored form or just something that we can easily do. So 2x squared minus 5x minus 3. So factors of -6 that give us -5 would be +6 and -1. So I would say 2x squared minus x plus 6x minus 3. Take out.
Would it be -6x plus x?
Yep, it would be. There we go. Put a cookie in the cookie jar. Huh? Okay, so then we've got, take out an x, that gives us 2x plus 1, take out a -3, x plus 1, nope, 2x plus 1. So then I've got x minus 3 and 2x plus 1, so x equals 3 or x equals -1/2 are my two vertical asymptotes. So in this case, I'm going to have 4 limits now because I have to have from the right and left of each one. So the limit as x approaches 3 from the left. So basically, I just would take and plug in numbers to your calculator to do this, just to speed up the process. But you can do, if you do the alpha y equals, it puts up a fraction for you, so you can just type in the numbers, and then you can, once you get that answer, you can do second entry and then just type in a different number. So I would do something like 3 from the left, 2.99. So 1 minus 2.99 divided by 2 times 2.99 squared minus 5 times 2.99 minus 3. And that's it's not a huge number, but obviously I'm only dealing with a small thing. So that would be going to infinity. Then if we do 3 from the right, I can take and do second enter, and that would bring up entry, and I can just type over it. So I can do like 3.01. And when I do that, I get basically the negative, almost same value of the other ones. That would be negative infinity. And then for negative 1/2 from the left, I would choose like probably negative 0.55 or something like that. I mean, it doesn't have to be anything crazy. Now, obviously, it's negative, so you're going to have to watch the signs when you type it in if you just type it in over top of whatever you had before. So that's a negative number. It's not super crazy, but if I chose a different number, say like 0.51 or something, it probably would look a little bit more drastic, but this one's going to be negative infinity. No, I lied. Yes, wait. Let me look at my signs, because I don't know if I flipped them all. So that should be a plus. Oh, I know what happened. I didn't put my squared on the outside. There we go. It's a positive number. So positive infinity, and then the limit as x approaches negative 1/2 from the right. Would be like 0.49. And typically you can assume they're going to go opposite directions as a pretty general rule, but it is always good to check, but that one would be negative infinity. All right. I think we'll stop there and we'll just pick up tomorrow because there's only a few minutes left, and that way we can do the last few things that all kind of roll together, because I think we would get close to finishing it all, but I still think we'd have like 2 problems left, so I'd rather just pause for right now.